Drainage and slope protection. Drainage is defined as the means of collecting, transporting, and disposing of surface water, originating in or near the right-of-way, or flowing in stream crossings or bordering the right-of-way. As you can see, ito ang itsura ng road right-of-way. Meron siyang vegetation line kung saan pinapreserve ang mga puno. At meron siyang drainage line na may luwang na 1 meter kung saan dito na i-imbak ang mga tubig para hindi mag-stuck sa kalsada. At meron ding shoulder line na may habang 3.05 meter at carriageway na may 6.10 meter. At may haba itong 20 meter. Types of a residential drainage system. Surface drainage system is the removal of excess water from the surface of the land. This can be done around buildings, walkways, or driveways to keep water flowing away from the structure. Subsurface drainage system is the removal of water from the root zone. Downspout and gutter system. The downspout is connected to the gutter system on a building or home and carries water away from the roof down to the ground. Slope drainage system. Slope drains allow water to generally take its natural course away from the structure and with the aid of pipes moving down a slope. Surface drainage problems follow 3 basic considerations. Hydraulic design that deals with estimating the highest rate of runoff to be handled. Hydraulic design deals with this selection of the kinds and sizes of the drainage facilities that are most economical to accommodate the estimated water flow. Number 3. Erosion control is to ascertain that the design will not create erosion or other unacceptable environmental conditions. So, ang hydrology pala ay applicable din siya sa highway because hydrology is a branch of physical geography that deals with the water of the earth. The branch of hydrology that concern highway engineers are: Number 1. The frequency and intensity of the precipitation. The frequencies that this precipitation brings the highest runoff, which is equal or exceeded critical values. The distribution of precipitation throughout the seasons that influences water behavior affecting the highway surfaces. The prediction regarding future rainfalls or runoff from gathered statistical approaches, formula or simulated methods based on the laws of probability. Runoff is predicted based on the following methods: by rational methods, by empirical formula, by the unit hydrograph, by statistical approach, by simulation. Diba, pag sinabi kasing precipitation, yun yung parang ulan, diba? Kung matatandaan natin sa hydrology. Tapos yung runoff, yun yung parang yung nawawala na tubig from the land. Relationships and effort of hydraulic and construction. Usually, highway construction disrupts the existing natural drainage pattern. Construction operations may disturb the ground cover and loosen the soil, creating a muddy stream because of erosion. Erosions create debris that is carried downstream and deposited at points where the velocity slackens. Any changes in the land use may alter the historical runoff or ungauged rural watershed that could be disastrous on a wide-scale basis. Ang sinasabi dito na ang pagsasagawa ng construction sa highway, parang nakakasira ito ng soil na pwedeng ikapahamak ng mga tao. Rules on drainage design. As much as possible, any existing drainage system pattern and soil cover should not be disturbed. Necessary changes in the drainage pattern should not in any manner bring velocities that may create new erosion problems. Drainage economic considerations. An economical quality structure, of course, if you are about to design drainage, you can look for its most important consideration. The economical design The term economy in drainage system means finding the solution to a problem that is cheapest in the end under the following conditions. Determine the estimated initial investment cost. Consider the maintenance cost or outlay. Consider anticipated loss and damage for each solution. Consider the maintenance cost of design. Under the previous deliberations, annual appropriation for possible drainage or uneconomic loss is equal to the estimated losses from floods of various magnitudes, multiplied by the probability that these floods will occur any time of the year. Drainage problem is varied and there is no single set of assumptions or rules to the economic problem in drainage considering the uncertainty of flood frequency, where the design is based to major highways with a large volume of traffic. Losses to motorists and the economy is tremendously high if the road will be closed often due to flood and washout. For major highways, projections might prove that drainage facilities should accommodate a 50-year flood, whereas the design based on a 5-year flood is reasonable for low-volume rural roads.
Drainage structures. Drainage structures are installed beneath or alongside the roadway for collecting, transporting, and disposing of surface water originating in or near the road right-of-way. A well-located, properly bended, accurately assembled, and carefully backfilled drainage structure will function properly and efficiently for a long period. Ang drainage structure ay kadalasan nating nakikita sa gilid ng kalsada. Ito ang nagde-drain, nagtatransport at nagdi-dispose ng naipon na tubig sa roadway. Mahalagang maayos ang pagkakagawa ng drainage, hindi lang para tumagal ito, kundi dahil malaki ang role nito upang maiwasan ang pagbaha, lalo na sa mga urban places. Manhole is the top opening to an underground utility vault used to house and as an access point for making connections, inspections, or performing underground and other services including water, sewers, storm drains, and many others. Ito ay isang opening o daan para makapag-access at makapag-inspection sa drainage upang ma-regulate na ito ay nagpa-function ng maayos, walang bara at sira. Next, inlet. Drain inlets collect water from roads and parking lots and convey it to an underground storm drain system. Ang inlet ay nagkokolekta ng tubig sa roads at parking lots papunta sa underground storm drain system o drainage. Next, channel. The purpose of designing a channel is to determine the cross-section of the canal that will accommodate water flow smoothly and the cheapest in construction and maintenance. It is also known as the irrigation canal, having a slope size in each size. Ginagamit ito para sa rapid evacuation of surface water sa mga lugar na medyo malayo sa canals o drainage. Madalas makikita ito sa mga garage. Some ratios that may be used in the designing channel section. Ang ratio ng side slope na ginagamit sa pagdesign ng channel ay 2:1 o mas flat pa. Sa pagde-design ng channel, nagbe-base din sa design ng crow ditches, gutters, stream channels, at culverts. Culvert construction. Culvert is defined as tunnel structure constructed under roadways or railways to provide cross drainage or to take electrical or other cables from one side to another. It is totally enclosed by soil or ground. Pipe culvert, box culvert, and arch culvert are the common types used under roadways and railways. Ito naman yung mga material na ginagamit para sa culvert construction. Culverts are like pipes but very large in size. They are made of many materials like concrete, steel, plastic, aluminum, and high-density polyethylene. Ito naman ang type ng culvert. Una, pipe culvert, pipe arch culvert, box culvert, arch culvert, and bridge culvert. 1. Pipe culvert, single or multiple. Pipe culverts are widely used culverts and rounded in shape. The culverts may be of single in number or multiple. If single pipe culvert is used, then larger diameter culvert is installed. 2. Pipe arch culvert, single or multiple. Pipe arch culvert means nothing but they look like half circle shape culverts. Pipe arch culverts are suitable for larger water flows, but the flow should be stable. 3. Box culvert, single or multiple. Box culverts are in rectangular shape and generally constructed by concrete. Reinforcement is also provided in the construction of box culvert. These are used to dispose rainwater, so these are not useful in dry period. 4. Arch culvert. Arch culvert is similar to pipe arch culvert, but in this case, an artificial floor is provided below the arch. For narrow passages, it is widely used. The artificial floor is made of concrete and arch also made of concrete. Steel arch culverts are also available but very expensive. 5. Bridge culvert. Bridge culverts are provided on canals or rivers and also used as road bridges for vehicles. For these culverts, a foundation is laid under the ground surface. A series of culverts are laid and pavement surface is laid on top this series of culverts. Reinforced concrete pipe culvert. Sa pagko-construct ng RCP culvert, mayroong 5 step. Una dito ay ang excavation. At ito ang mga kailangan i-consider sa pag-excavate. Sa excavation, backhoe ang suitable na gamitin, especially kapag pipe culvert or segmental type box culvert, dahil hindi lang to during excavation magagamit, pati na din sa paglilip ng culvert during installation. Pag naman hand method, kailangan maglagay ng string para maset ang boundaries ng huhukayin. Ang trenches or stream bed ay kailangan fit sa ilalim ng culvert. Hanggat maaari, ang trenches ay makitid pero sakto lang ang lapad. Sa pag-install ng stream bed, yung base dapat uniform at stable sa entire length of structure. When excavated grade line crosses o matapat sa spots na malambot at matigas, ang foundation ay kailangan uniform dito. Pangalawa ay foundation fill. At ito ang mga kailangan i-consider sa foundation fill. Kung ang soil na paglalagyan ay composed ng unsuitable material, kailangan itong tanggalin at palitan ng buhangin o mabuhanging lupa. Ang foundation fill ay nilalagay para maiwasan ang settlement ng lupa sa isang drainage. 20 cm ang usual na kapal ng foundation fill. Pwede itong ikalat manually gamit ang rakes and shovels or mechanical equipment hanggang makover ang buong foundation. Para naman sa box culverts, kailangan uniform ang thickness ng layer. At para sa circular pipes, kailangan nakashape sa pipe yung foundation at nakalapat ito. Pangatlo ay installation of pipes. Sa pag-install ng pipes, ito ang kailangan i-consider. Ang pipes ay naka-install sa natural stream bed kasunod ng natural canal or channel. Sa pag-install ng pipes, kailangan unahin yung downstream para magamit ang gravity sa flow ng water. Ang groove end pipe ay nilalagay upang ma-fit ito sa susunod na pipe at makonect ang dalawang pipe. Ang lower segment ng bawat pipe ay kailangan nakalapat sa bedding sa full length nito. Pang-apat ay collaring of RC pipe. Sa pagko-collar ng RC pipe, ito ang kailangan i-consider. Ang mortar proportion sa collaring ay 1:2 at depende ang desired consistency sa water flow. Ang collar ay ginawa para makover ang mga tuktungan ng bawat pipes at para ma-ensure na konektado ang bawat pipe. At sa pagkakabit nito, kailangan ang loob ng pipe ay okay na at nakalapat ng maayos. Panglima at panghuli ang backfilling. Sa backfilling, ito ang kailangang i-consider. Ang paglalagay at pagko-compact ng backfill ay hindi dapat lalagpas sa 15 cm each side at 30 cm ang elevation sa taas ng culvert. Sa pag-spread ng backfill, pwede itong gawin manually gamit ang rakes at shovels sa manipis na layer para maging madali ang pag-compact ng material gamit ang hand tempers para masiguro ang temped ang backfill. Pagkatapos ng backfilling, magpo-provide ng extra fill para maging cover at proteksyon ng pipe culvert bago pahintulutan madaanan ito ng mga heavy equipment para ma-ensure na hindi ito madadamage. Draining the highway. Rainwater runs literally or obliquely on the surface of the road pavement under the influence of cross-section slope or super elevation in the pavement and shoulder. If the water flow is controlled, then the shoulder is in danger of erosion. However, the shoulder damage caused by erosion will be minimal if covered or protected by turf or grass. Yung tubig ulan umaagos sa kalsada ng nakaayon dito o pahilig dahil sa cross-section slope or super elevation. Kaya naman yung tubig na pupunta at naiipon sa shoulder na maaaring mag-cause ng erosion, kaya mainam na may cover itong turf or grass para maiwasang madamage. Prevention of slope washout. Ito ay mga paraan upang maiwasan ang pagka-washout ng slope. 1. Dapat yung water na magpopol mula sa roadway pababa sa road slope ay kailangan manipis at di rumaragasa upang ma-minimize ang erosion sa shoulder. 2. Yung unprotected slope ay pwedeng ma-wash out kapag nag-accumulate yung tubig sa part ng shoulder na may lubak, tapos sa agos papunta sa slope. Kapag may sag ang road, may tendency na doon mag-accumulate yung tubig na makakaapekto sa shoulder. 3. Isang paraan upang maiwasan ang washout sa side ng slope ay panatilihin at dapat napupunta ang tubig sa outer edge ng shoulder. 4. Maaaring maglagay ng crown ditch at intercepting channel sa top of the cut slope upang maiwasan ang erosion na maaaring idulot ng flow of water galing sa bundok. 5. Hindi dapat galawin yung surface ng slope kapag yung natural ground ay mayroon ng ground cover tulad ng halaman at damo. 6. Ang channel o kanal ay dapat i-form na yung natural ground ang bed ng kanal at dike ng soil or any imported materials naman yung bank para ma-hold ang tubig. 7. Scoring must be controlled. If possible, i-divert yung flow ng tubig papunta sa mga intervals para yung flow ng tubig ay limited lang sa safe amount. Yung tubig ay dapat bumababa sa mga roadside ditch sa pamamagitan ng channel o kanal. Draining the urban street. Ito yung mga paraan sa pagde-drain ng urban street. 1. Sa city streets, yung tubig galing sa ulan mag-flow sa slope to gutters, then mapupunta sa mga inlets para malesen yung pagpunta ng tubig sa kalsada at para di maipon. 2. Ang nirecommend ng American Association of State Highway and Transportation Official o AASHTO ay hindi dapat maaabot ng tubig ang outer lane by more than 1.8 meters for 10 years flood. 3. The decision for water storm inlets and connection for gutters and depressed median ay kailangan nakabase sa recommend ng AASHTO. Ang pangunahing storm drain para sa freeway ay kailangan kayang umakomodate ng 50 to 100 years of storm. 4. For arterial, ang arterial road ay high capacity urban road, highway, or expressway. Ang return interval ay 20 to 50 years. Ito yung average time para ma-occur ulit yung event, which is in this case, yung water flow that can last up to 20 to 50 years. The water flow estimate was based on the rational formula using the value of runoff coefficient between 0.8 and 0.9 for pavements, 0.4 and 0.6 for gravels, and 0.1 and 0.7 for grass.
Good afternoon everyone. My name is Nathan J. Rogel and I am going to discuss the determination of quantity of runoff. First, rational formula. Q is equals to CIAD, where Q is equals to quantity of runoff in cubic foot per second. C is equals to runoff coefficient expressing the ratio or rate of runoff to the rate of rainfall. I, intensity of rainfall in inches per hour for a duration equal to the time of concentration. AD equals to drainage area in hectares. On the freeway and urban streets, the inlet for median and gutter should pass the design. Flood without clogging, in with debris. Dito naman yung suggested value of coefficient of runoff for use in the rational formula. First type of drainage, concrete or bituminous pavement, runoff coefficient niya 0.8 to 0.9. Next, gravel roads are open, 0.4 to 0.6. Bare earth, high value for steep slope, 0.2 to 0.8. Turf meadows, 0.1 to 0.4. Cultivated fields, 0.2 to 0.4. Forested areas, 0.1 to 0.2. Legal aspect of drainage. Floodwaters usually carry objectionable objects like brushes, banana trunks, tree branches, etc. This floating debris clogs culverts, entrances, and raises the headwater elevation, overflowing the road and damaging adjoining properties. Dito sasabi dito na sa baha maraming sumasamang kalat na bumabara sa drainage na nagsasanhi ng pagtaas at pag-overflow sa mga area na maaaring masira dahil sa baha. Tapos meron daw dito naman na maaaring dalawang dahilan kaya ito nangyayari. Una, yung the result of the agency's project wherein the flow of several streams or creeks were concentrated into a single channel that resulted in erosion, silting, or flooding of private property. Sinasabi dito na maaaring may mga flow ng tubig na nakakonsentrate lang sa isang daluyan o way ng drainage na nagdudulot ng erosion at pagbaha sa ibang lugar. Due to poor design or inadequate maintenance, water back against the highway or embankment resulted in a flood of land, property, cause an injury or death. Ang hindi maayos na pagkakagawa daw o hindi sistemadong paraan ay nagsasanhi rin ng pagbaha o maaaring mag-cause ng aksidente. Roadway designs and construction for unusual soil condition. As ito naman yung problems na usually na-encounter sa pag-design at pag-construct ng roadways. First, the stability of field, and second, the drainage. Third, capillarity. 4, permafrost. In other countries with winter season naman yon, sa pambansa lang na may winter. And last, elasticity and roughing. Capillarity is the tendency of water to seek its level as if an open channel now through the pores and fine channels of the soil. It is the force pulling free water through the voids of the soil in all direction. Capillary action is most common in permeable materials such as dirty gravel and soils mainly of fine sand, silts, or clayey silts. Capillary flow, however, is less common in impermeable materials like clay and colloidal soils. Sinasabi dito na yung capillary daw ay yung paghanap ng tubig na mapapasukan. Kasi yung pag-flow ng water yun yung pag-flow ng water sa soil. Kasi alam naman natin na 'di ba yung liquid ang tubig, kaya kahit maliit na space lang kaya niya na mag-flow. Kaya kung mas dense yung surface, mas less yung pag-flow ng water. Moisture in the roadway is brought about by changes in weather, seasons, or by the capillary action of water. Ito yung moisture sa daan or sa roadway ay dulot ng pabago-bagong panahon, klima o yung kanina na capillary action of water. In roadway construction, moisture has to be controlled. Saturation of the soil in the road to The structure reduces its strength and differential expansion of the soil. The uncontrolled moisture may lead to serious problems. Sinasabi lang dito na yung sa road construction dapat yung moisture niya control kasi nga nakaka-reduce ng strength ito na structure na nag ng expansion soil na hindi na control na pwede mag-lead sa serious problems. Next, water movement due to capillarity action takes place in any direction and an upward movement may create undesirable conditions. Sinasabi dito na yung pagdaloy ng tubig due to capillarity action ay magiging sanhi ng pagbago ng direksyon na maaari magdulot ng hindi kaaya-ayang kondisyon. Next. Ito naman yung presentative heights of capillarity rise in soil. First type of soil, small gravel. Approximate capillarity height niya in centimeter is 2 to 10 centimeters. Second type of soil, coarse sand. Tapos yung approximate capillary height niya is 15 centimeter. Elasticity and erosion. Elasticity is common in soils whose fines consist mainly of flat and flaky particles. This kind of soil has a rubberous characteristic that rebound under heavy loads. The deflection of the pavement surface as the wheel slowly rolls past the reference point is measured by a measuring device called Benkelman beam A. A long, slender bar slips into the space between the dual tires of the truck wheels. The deflections rate of travel shock wave recorded. Dito naman sa elasticity and erosion, sabi dito na yung may type kasi ng soil na flat and flaky, and usually yung flat and flaky soil yun yung mas madali makompress kasi nga mas malaki yung open spaces nila. Yun yung mga soil na kapag tinapakan mo medyo lulubog pero babalik din sa dati kasi may rubberized characteristics ito. Yung tawag naman sa ginagamit na pang measure ng pagkalubog or pagdeform ng soil ay Benkelman beam A. Tapos ito yon. Ito yung ginagamit na tool. Benkelman beam A or Benkelman beam apparatus. Next. Highly plastic soils should not be placed closer to the roadway surface where heavy loads are expected. Early cracking of the pavement may happen due to deformations caused by the rebound of soil. So, yung sinasabi naman dito na yung plastic soil daw ay highly flexible siya kaya hindi siya pwede sa mga highway kasi madadaanan yun ng mga heavy load like trucks. Masisira lang dun yun kaya hindi dun nilalagay. Tapos yung rebound, yun yung soil na nade-deform kapag nadadaganan na mabibigat pero babalik sa dati kasi rubberized siya. Yung ano na yun, rebound yung tawag doon. Kaya yung madalas na pag-rebound nakakasira ng soil which can lead sa pag-crack. Next, slope protection. Slope protection or retaining structures are constructed along the side of the road as protection from erosion or if there are space constrictions. An existing earth slope that has been stable can experience significant movement called slope failure or landslide due to the following physical change. Yung sabi dito na ginagamit yung slope protection sa mga slope surface kasi iba yung ibig sabihin ng slope is tagilid yun. Kaya pag ginawang daan yung slope surface, nilalagyan ito ng slope protection para iwas sa landslide. Iwas accidente. Next. Changes in natural condition may be result of the first occurrence of an earthquake, second subsidence of underground cavern, third erosion, next slope weakening due to the development of cracks and shrinkage cracks that are followed by water intrusion, next variations of in the elevation of groundwater or changes in the slope subsurface flow that create new seepage forces. A weakening of buried soil or rock winds due to groundwater flow or chemical leaching. Increase on the near its crest. Removal of the earth below the slope. Removal of or from slope making it steeper. Topographic modification like earth moving excavations. Changes in elevation from one area to another, which may create slope failure. A landslide, other condition caused by man. At sinasabi lang dito na yun nga yung maaring yung pagbabago maaring sa natural condition tsaka sa man-made conditions din yung mga magawa din ng yung mga mga condition na caused by humans ganun. So hanggang dito lang po yung report ko. Thank you.
Greetings, ako si Jonathan EBS Santiago. Ang sakop ng aking report ay about slide, slope stability, slope protection structures, construction of grouted riprap, and construction of stone masonry. Slide. Slides refer to the occurrence where the moving mass is defined and separated from the underlying and adjacent earth by plane, comprising several adjacent planes where the seepage results. The seepage plane represents the continuous surface where the maximum shear strength of the earth materials has been reached, with the result that large displacement occurs. So, ang slide ay ang paggalaw ng mga soil mula sa itaas pababa. Nangyayari ang slide kapag ang nag-hold sa mga soil ay bumigay dahil yung bigat or load ng lupa ay hindi na nakayanan. Parang landslide, ganun. Yung seepage naman, yung makikita na parang pahukay kung saan naganap ang slide. 4 types of slide: rotational slide, transitional slide, block or wedge failure, flows and spread failure. Yung sa rotational slide, ito ang nangyayari kung ang slide ay may nabubuong pa-curve or pa-concave. Yun yung tinatawag na seepage. Yung transitional slide naman, ito yung uri ng slide na nagre-resulta ay flat surface lang. Yung block or wedge failure, ito yung type ng slide na malalaki ang portion ng soil or mass ng soil ang bumababa or bumibigay. Sa flows and spread failure naman, ito yung movement ng soil ay lateral at makikita na ang pagbaba niya ay pakalat at hindi nag-accumulate. Nangyayari ang type ng flow na ito dahil sa property ng soil na bumababa ay may pagka-moist or wet. Next naman is slope stability. Slope stability is the potential of soil-covered slope to withstand and undergo movement. The balance of shear stress and shear strength determines stability. Sa slope stability, dito malalaman kung gaano kabigat ang mare-resist na force ng mga soil. Pag ang shear stress ay hindi nalagpasan ang shear strength, matatawag na stable ang soil at hindi magre-resulta ng slide. So kung may stability na ang soil, isang factor na lang ang makaka-apekto dito. Ito ay yung mga climatic events or halimbawa, bagyo, ipo-ipo at iba pa. Improving slope stability. Slope flattening and proving a berm beneath the toe of the slope.
Mga paraan para maging effective ang stability ng slope ay gagawin siyang mas flat or pababa imbis na matarik. Pag mas flat ang magiging surface, mas maiiwasan ang pag-slide ng mga earth materials or soil. At yung sa proving a berm, ito naman yung nilalagyan ng object na nagpapahinto sa paggalaw ng mga soil. Slope protection structures. Slope protection structures are retaining wall, gravity wall, cantilevered wall, sheet piling wall, and anchored wall. So, una is retaining wall. Sa retaining wall, makikita na ang slope ng soil ay may iba't ibang elevations. Sa design na ito, nare-restrain ang movement ng soil. At sa paraan na ito, hindi magiging steep or may pagka-vertical ang slope na maaaring magresulta ng bigla ang pag-slide. Sa gravity wall, makikita na may nakapatong lang na object vertically na ang purpose ay mapahinto ang paggalaw ng soil. Kaya naman natawag na gravity wall is yung mass ng object ang magdedetermine ng force na maresist niya. Halimbawa, mas mabigat yung object, di ba mas mahirap siya itulak? Sa cantilevered wall naman, makikita na may pa-horizontal part ang object na ginagamit sa pang-stop sa movement ng soil. So, ang purpose nun is para magamit yung weight ng ibang object para makadagdag sa pagtatag ng wall. At sa cantilevered wall naman, mas may iwasan ng pagtaob ng wall dahil may tumutulong na force dun sa wall para hindi mag-rotate. Sa piling wall, makikita na ang object ay mas nakabaon sa lupa kung saan siya ay inilagay compared sa iba. Ang design na ito, makikita ang support ay nanggagaling mula sa ilalim. At sa anchored wall naman, makikita na ang support ay nanggagaling mismo sa portion ng soil na kanyang pinapahinto. Other slope protection structures: grouted riprap, stone masonry, gabions, and plain or reinforced concrete. Construction of grouted riprap. So sa picture na ito, makikita natin kung ano ang grouted riprap. Construction of grouted riprap. Excavation of foundation. Ito yung pagsisimula or pagsasaayos na magiging foundation ng grouted riprap. Use of batterboards as guide. Good workmanship requires a reliable reference to guide the work up to completion. The unevenness of the embankment slopes is then trimmed using shovels and rakes, and the high areas are removed and patched and compacted to low areas until a flat surface is attained. So, yung batterboards as guide, ginagawa ito para maging maayos tignan ng kakalabasan ng grouted riprap. Laying of boulders and grout. Boulders and grout are placed layer by layer alternately. Each stone is laid with its longer axis perpendicular to the slope in close contact with the adjacent stone. The riprap is thoroughly rammed into place and the finished stone is laid to an even tight surface, and the spaces between stones are filled with cement mortar, sufficient enough to fill all the voids. Sa procedure naman na to, sineset up yung mga boulders na pagpapatong-patungin para magkaroon ng height. Tapos bubuhusan ng cement para maging solid at matibay yung kinoconstruct na grouted riprap. Makikita sa picture kanina na may mga nakabuhos na cement sa pile ng mga boulders. Finishing work. Cement grout is placed starting from the bottom to the top of the surface and then swept with a stiff broom. And after grouting, the surface is cured for at least 3 days from the date of installation. Importance of weep holes in slope protection or retaining structures. Weep holes are opening provided to permit draining of water in the filter layer or soil layer from behind the structure, and if no or insufficient weep holes are installed, this will cause oversaturation of the embankment and the road structure. So ito yung isang itsura ng weep holes. Kaya nilalagyan ng weep holes, siya yung magsisilbi na daanan ng mga natatrap na tubig sa likod ng ginawa na structure. Dahil pag yung natatrap na tubig is nagstay for periods of time, ma-absorb ito at mas mapapadali ang pagkasira ng structure. Construction of stone masonry. So, dito naman sa picture na ito, makikita natin kung ano ang itsura ng stone masonry. Excavation of stone masonry foundation. The foundation bed where the masonry is to be placed should be firm and normal to the face of the wall, and the bed that will receive the stone should be clean and moistened before the mortar is spread. Dapat yung paglalagyan ng stone masonry ay matibay para maiwasan ang mga maaari maging problema, at dapat yung paglalagyan din ay malinis at moist. Use of batter boards is essential to produce good workmanship. As in grouted riprap, batter boards are necessary to keep lines and grades of the finished stone masonry structure in accordance to the lines and grades of the plans. Katulad din sa grouted riprap, yung batter boards, siya yung napapanatili sa ayos or nasa plano pa din ang kakalabasan ng stone masonry. Kumbaga, ito yung magiging guide habang kasalukuyang ginagawa yung structure. Laying of boulders and grout. Large stones are used in corners. Bunching of small stones of the same size is not allowed. Stones are laid with their longest face horizontal in full beds of mortar. Joints are flushed with mortar. The exposed face of individual stone should be parallel to the face of the wall in which stones are set, and the stones are handled carefully so as not to jar or displace the stones already set. So, ito naman yung mga procedure na dapat sundin para mapanatili yung strength ng structure. And finishing works. Immediately after laying and while the mortar is still fresh, all face should be thoroughly cleaned of mortar stains and should be kept clean until the work is complete. So dito naman, after ng mga procedure, yung makikita na mortar sa face ng stone, tinatanggal na habang hindi pa nagseset dahil mahirap na ito tanggalin pag natuyo na, at dapat minamonitor para mapanatili na malinis ang stone masonry.
Hello, I am Scientist Rodriguez and I'm going to report the stone masonry material specification. So, boulders, thickness of not less than 150 mm and width of not less than 1 1/2 times the respective thickness and length of not less than 1 1/2 times their respective widths. Mortar, composed of 1 part of Portland cement and 2 parts of fine aggregate by volume and sufficient water to make a mortar such consistency if it can be handled easily and spread with a trowel. Yan yung nilalagay sa loob ng hollow blocks in short. Construction of gabions. Wire mesh in varying thickness and width is built with boulders in place to form a slope protection structure. Boulders should be hard and durable rock pieces that will not deteriorate when submerged in water or exposed to severe weather conditions. Boulder size should be uniform graded general ranging 10 to 20 centimeters. Build gabions should have a minimum density of 140 kg and boards distributed evenly. Yan yung pag may malakas na ragasan ng tubig, mapipigilan na para saka dapat matibay siya para din equal. Installation procedure of gabions. Only simple tools are needed to assemble these wire baskets such as long nose fencing pliers and crowbars. Before the closing of these gabions, mortar should be overfilled by about 25 mm to allow for settlement. The leads are then stretched over the stone fill and laced down. Corners are secured first to make sure the lid can be laced down without overstretching the mesh. The leads are laced down securely. Flooding control. Types and causes of floods. Coastal and urban floods. Coastal floods due to severe storms creating high waves. Yung coastal flood, yun yung mga flood tinatawag pag malapit sa dagat. Urban floods occurs when there is a lack of storm water drainage. Yun yung bumabaha kasi barado o hindi maayos yung pagkakagawa ng water drainage. Yung river or fluvial floods occurs when an extended period of rainfall, the water rises over the banks. Yun yung magdamag umulan, ngayon umaapaw, gano'n. Yan yun. Categorize of flood control according to purpose. To increase the river discharge capacity to protect flood-prone areas from overflow, to reduce and or control the peak discharge of flood, to prevent inland flood, to prevent bank collapses and harmful degradation of the river bed, to prevent obstruction against river flows and or maintain conserve the good condition of the river to keep the flow uninterrupted. Design flood frequency. All flood control projects must have a flood control plan. It is necessary to make a flood control plan based on the forecast river phenomena which is likely to occur because of the discharge corresponding to the design flood frequencies. Design flood frequencies is expressed by term period. The probability expresses in years where a flood of a target size magnitude is likely to occur during the period should be determined based on the size of the catchment area, the degree of importance of the proposed project area, and the economic viability of the project. Thus, it is necessary to determine the design flood discharge corresponding to the design flood frequency of the river. It also necessary to consider the funds needed to implementation of the proposed improvement works and the expected benefits. Flood control drainage structure. Increase the river discharge capacity by dike, by widening of waterway or degrading evacuation or combination of the all. Yan yung dike paglalagay ng ng mga parang harang sa ilog para hindi agad kung sakaling tumaas ang tubig ay hindi agad ito tatakbo sa mga mababang lugar. Flood protect flood-prone areas from overflow, to reduce and or control the peak discharge of flood, to prevent inland floods, lateral improvement, storm drain, main drainage ditches and open canal or tributary improvement, prevent bank collapses and harbor degradation of the riverbed, prevent obstruction against river flows and maintain conserve the good condition of the river.
Good afternoon, everyone. I am Maria Catrina M. Sabado, and I'm going to continue the discussion regarding flood control. So, let's start. Two types of flood control measures. First is the structural measures, and then the non-structural measures. When we say structural measure, it refers to those disaster management or mitigation tools which have physical entities such as embankment, flood or cyclone shelter, and dams. And when we say non-structural measure, it can never be completely eliminate the risk of flooding, but it is a prevention for the possible risk of flood, like flood forecasting and warning, flood proofing, prevention, and shelter management. And let's have the examples of structural measures. We have here the dike, revetment, spar dike, ground seal, dams, and others like floodgate, roadside canal, and cut-off channel. And now we have the explanation of each structures. First is the dikes. An embankment, also called a levee, constructed along the banks of a stream, river, lake, or other bodies of water for protecting the landside from an overflow of flood water and confine the stream flow to its regular channel. So, yung dike, ito yung nagsisilbing barrier para kung sakaling magkaroon ng mga malalakas na pag-ulan or bagyo at tumaas yung level ng water sa mga ilog or other bodies of water ay hindi nito maapektuhan yung mga mabababang lugar or especially yung mga community na malapit dito. Hindi siya magkakos ng flood. Next is the components of dike. We have here the freeboard, a margin of height maintained between the top of the dikes and the design flood level to guard against overtopping and wave wash. So, pag sinabing freeboard, ito yung tawag dun sa distance between the design flood level hanggang dun sa peak ng dike, peak level ng dike. So, yung allowance na to, siya yung magsisilbing tanda na kung yung tubig ba ay tumataas na or pwede nang makakos ng flood sa mga komunidad na malapit doon sa bodies of water. So, next is the dike crest. Dike crest width may not be special if ample freeboard and side slopes are already provided. Crest width mainly serves road access for the transport of materials and maintenance operations. So, yung dike crest, ito yung sinabi ko kanina na peak nung dike. So, yung dike crest, ito yung nagsisilbing road ng mga construction kung saan dito tinatransport yung materials and syempre pag nagkakaroon ng maintenance sa mga dike. So, next is the side slope. The slope of a dike shall have a gentle gradient of 2:1 horizontal and vertical or less. The slope is decided based on the dike's body. A gradient steeper than 2:1 is generally not preferable because of the stability conditions of a slope face. Ang side slope naman, ito yung pinaka-katawan ng dike. So, si slope, ito yung magsasabi kung yung lugar ba na pinagtatayuan niya is madaling pasukin ng tubig mula doon sa, for example, ilog. So, yung gradient niya is nakabase doon sa history ng lugar kung siya ba ay madaling puntahan ng mga pagbaha. So, next is the berm. Berm serves as a landing area for maintenance operation and patrolling purposes. So, gaya nga nung kay dike crest, si berm, siya din yung nagsisilbing area for maintenance operations and also for patrolling. Ito yung makikita natin sa mga dike na parang may hagdan or merong flat area kung saan pwedeng madaanan sa ibaba ng slope. So, next, the main causes of damages in dikes. So, meron tayo dyang erosion. Ayan, yung erosion, ito yung pagguho ng lupa or yung pagbaba ng lupa na pwedeng maka-apekto dun sa mga dike. And then, we have the overflow. Yung overflow na to, ito naman yung kapag nagkaroon ng pag-apaw ng tubig mula dun sa, sabihin natin, ilog. Yung overflow na to is makaka-apekto din siya para magkaroon ng landslide or erosion. So, next is the seepage. Yung seepage naman, nangyayari to kapag yung dike ay nagkarak or nabutas dahil sa mga earthquake or again, galing sa erosion. Lumalabas yung tubig sa part na butas na may crack at gumagawa ito ng daan para mapunta sa kabilang side na pwedeng maging cause ng flood. And next is the earthquake. Yun na yun. And rebatements. Yan. A rebatement, a direct countermeasure against the collapse of river banks due to erosion, scouring, and riverbed degradation. The planning and construction of the rebatement, the main factor is considered is the river flow velocity, embankment, materials, topographical and geological condition of a river, and river flow direction. So, etong si revetments, ito naman yung nagpo-protect kay dike sa mga dike or sa mga seawall against dun sa mga erosion by actions or the storm surge and current. And itong si revetment is example din ng kanina natin structural measure. So we have the components of revetments. We have the freeboard again. Freeboard. Minimum freeboard allowance of 0.6 meters above the maximum of experienced flood level or design flood level, as the case may be, is provided for revetments confining flood flows. So, si freeboard is gaya lang din nung kay dike kanina, siya yung nagsisilbing allowance doon sa ating revetment. And next is height of revetment. The height of revetment depends on the longitudinal profile and cross-sectional profiles and maximum flood level or design flood level. Si height of revetment naman is nakadepende naman siya kay design flood level, yung pagkakatayo niya. Then, we have the berm again. If the height of revetment is more than 5 meters, berm must be provided to separate the revetment into segments. So, yun lang din yun, katulad nung sa dike kanina, same purpose, and nagkaiba lang sila sa sukat. And then, we have the depth, o yung lalim. For a narrow river, the minimum depth of revetment foundation should be 1 meter below the deepest riverbed elevation for the original riverbed or design riverbed, because riverbed materials are subjected to erosion during flood times. Ayun, madali daw siyang maapektuhan ng mga erosion kapag nagkakaroon ng mga pagbaha. Kaya yung size niya is medyo may kalaliman. So, yan. Kung makikita natin sa picture, is 1 meter yung deepest riverbed, and yun. Next is the segment length. The segment length of one segment of revetment is the longitudinal direction should be less than 50 meters to prevent the extension of damage once the section of revetment collapses. The edge of the segment end shall be adequately filled with joint material to connect with the adjoining revetment. So, another is the slope. The slope, kagaya lang din ng kanina, is nakadepende yung slope natin dun sa history ng lugar kung siya ba ay madaling maapektuhan ng pagbaha. So, thickness. Thickness yung kapal. The thickness of revetment is generally decided based on the existing flow velocity sediment runoff whenever the latter exists or likely to occur in the proposed improvement stretch. So, si thickness naman, kung si slope is nakadepende doon sa history ng kanyang lugar, kung siya ba ay madaling magkaroon ng pagbaha. Si thickness naman is based on the existing flow velocity, yung flow ng stream or ng bodies of water. And syempre, yung sediment runoff kapag nagkakaroon ng mga improvement na gaya ng topography and geological conditions. So, we have here the whip holes. Whip holes is used as a draining pipe. It should be staggered, placed in a horizontal direction and spaced 2 meters center to center. Yung whip holes natin, ito yung ginagamit to drain out water from back of the revetment to release pressure. Yung whip hole, ito yung ginagamit kung saan para hindi magkaroon ng pagkamuo ng mga tubig doon sa likod ng ating revetment. And next, we have the filter cloth and gravel. Filter cloth and gravel are used to prevent caving in of soil particles behind the revetment. Si filter cloth and gravel naman, ito yung part ng revetment natin kung saan iniiwasan niya yung pagkakaroon ng uka doon sa likod ng ating revetment. Kasi once na nagkaroon ng uka doon is pwede siyang mag-cause ng erosion o yung pagbagsak ng ating structure. So, kung makikita natin sa ating picture, yung ating letter A, whip hole without filter, cloth, and gravel. Ayan, nagkakaroon siya ng cave-in. So, madaling masisira ng tubig yung ating revetment. And sa letter B naman, whip hole with filter, cloth, and gravel. Ayan, napoprotektahan niya yung ating dike dahil walang cause sa kanya na pwede siyang masira. So, that's the end of my discussion. Thank you.
Good afternoon, everyone. I'm Faith Mariel Pirupenta. Today, I'm going to discuss the main cause of revetment damages. So, kung makikita nyo sa picture, ang revetment ay ito yung mga harang natin upang maiwasan ang matinding pagbaha. Ang main cause ng damages nito ay una, riverbed degradation. Pangalawa, high velocity flow. Pangatlo, damage at the end section due to direct water attack. Pang-apat, outflow of fine materials behind the revetment. Panglima, residual water pressure. Pang-anim, erosion on the top of water revetment. At ang huli, direct hit by big boulder. Magkakaroon ng pagkasira ang ating revetment kapag may matinding ulan na nagkokosya ng matinding pagbaha. So, ito yung revetment natin kung paano siya dinidesign. Spur dikes. Structure that serve as a flow roughness to reduce the river flow around the river bank and redirect flow away from the bank. So, ang spur dikes, ito yung nakikita natin sa mga minsan sa mga mailog na hinaharang nila para maiwasan ang matinding ragasan ng tubig. Two types of spur dikes. Una, permeable type. Spur dikes of this type is made of piles and frames. Second, impermeable or semi-permeable type. This type of spur dike is made of wet masonry or concrete blocks and loose boulder, preferably in series. Components of spur dikes. First, length. Second, crest. 3. Spacing. And 4. Toe protection. Next, ground seal is a flood control structure that prevents further degradation. So, alam naman natin, isa ang degradation sa pagkasira ng revetment. So, itong ground seal, pinipigilan niya yung pagbaba ng riverbed o kaya nung mga lupa na nandun sa isang surface. Floodgate is a flood control structure that connects the culvert passing through the dikes and its gate. Two purpose of floodgate. First, drain inland water into the river. Second, draw the water from the river from irrigation use or some other purposes. Dams are hydraulic structures that are constructed to meet the needs such as flood mitigation, creation of freshwater storage, generate power, and creation of recreation area. Non-structural measures. First, floodplain management. Second, watershed management. Third, disaster management. And fourth, solid waste management. So, itong apat na to, sila yung mga management or yung mga namamahala upang maging malinis ang ating mga dams.